Okay, so let's take a look at the factoring review here. Now remember, when you're finding the GCF, or the greatest common factor, all that we're really looking for is what values can be pulled out of every term. So when I look at number 1 here, I have a 9 and a 45 for the numeric values. And I know that 9 can come out of both of those. So I'm essentially dividing both terms by 9. I also see that they have a letter in common. They both have an x. So when I factor out a 9x from both of these terms, this is the quantity I'm pulling out. Then I have x here, because 9x squared over 9x would just leave me with an x. And then I would have a plus 5. You can always double check yourself by distributing back through. And I see I have 9x squared plus 45x. So I've done that correctly. When I go on to number 4, let's move down to number 2 here in order first. I see I have 5, 20, 15. So I'm going to divide each of these by 5. And they also each have an x. And this one actually has 5, then 4, then 3. So I can actually pull out x to the third from every one of these quantities. So again, I'm going to remove 5x to the third. And when I divide each of these, that's just going to leave me cancels. X to the fifth over x3 subtracts. That leaves me x squared. And then I have plus 20 over 5 is 4 and an x. And 15 over 5 is a 3. And I move down to number 3. And I see an 18 and a 6. I can pull a 6 out of either of those. And an x3 and an x, I can take out an x. So I can remove a 6x from both terms. And this is going to go in 3x2. And this one just once. We'll do the same thing up here. I see a 3 goes into each. Now I can't take an x out because this negative 33 does not have an x term. So I'm going to remove a 3. Now 3x squared divided by 3 is just 1x squared plus a 4x minus 11. So we're just essentially finding what divisor, what goes into every term within the polynomial. And there we go with our greatest common factor. Let's scroll down here to the next section on factoring. Now we're going to look at factoring trinomials where a is equal to 1. So when I do these, I'm just going to use my x. Now when a is equal to 1, all it requires is the x. Now remember, the x is the product, or the top, of your first and last term. This is 1 and 6, so that makes a 6, and then the middle term goes in the bottom. Now I'm looking for factors of 6 that I can make a 5, and I see there's actually 2. So I know that one of these, when they're multiplied, gets 6. When I add them, I get 5. And I know it's actually going to be 2 and 3 in this case. So those are my two terms, x plus 2 and then x plus 3. And you can always FOIL them back out to double check yourself. When I do number 9 over here, first and last term leaves me with a negative 14 in top. Middle term, negative 5 in the bottom. Looking for factors of 14. It'll make a 5. I see I have a pairing right here. Now when they multiply, these would get a positive 14. I need a negative. And when I add them, I get a negative 5. So I know at the 7, the larger item is going to be the negative. 2 times negative 7 is negative 14. 2 minus 7, negative 5. And there's my terms. Okay, let's skip down to the next problem set. Do number 7 here real quick. These are done in the same manner, just using the x. First and last term is a 20. Middle term in the bottom. And factors of 20, they can make a 12. And I see that I can get those with a 2 and a 10. And because the top is a positive but the bottom is negative, both of these terms are going to be negative. Negative times a negative produces a positive, and then when I add these two, I get the negative 12. And there are my factors. FOIL it out and expand it, and you'll get this trinomial. Let's look at number 8 real quick. Product of first and last, that's 1 times negative 3. Middle term in the bottom. And I can see that that's going to be 1 and 3 with the negative 1. Negative 1 plus 3 gets me the 2. Multiplied gets me the negative 3. And we'll come over here, do number 10 real quick. Product of the first and last. Notice on this one there is no middle term, so this could actually be written as x squared plus 0x, so the middle term 0, minus 36. This is a special case. So I have negative 36 in the top, 0 in the bottom. So I need factors of 36. It'll make a 0. And I'll see it actually goes to, put it over here, 6 and 6. So negative 6 and a positive 6 makes a negative 30, but when I add them I get 0. This is a case called the difference of squares. Now when I get down to this last problem set, or last type here, you have to add in a second part to the x. These ones require the x box method. So I'm going to start with my x and use it in the same manner. 5 times 6, product of first and last, and then the middle term. And factors of 30 that make a 13. And I can see it right here with 2 and 15. Well, double check. 2 times 15 does make a 30, but 2 and 15 does not make 13. And if I make this a negative 2, I'll get my 13, but now I have a negative 30. So that's not the correct pairing. So you have to double check. How about 3 and 10? Let's try those two. And 3 times 10 is 30, 3 plus 10 is 13. So that part looks good. Now, in this case, I need to use the box in order to finish it. And we put our first term in the first box, last term in the last box, and then we put our two middle terms. This is 3x and a 10x. What we do with the x here with this is we figure out how this 13x is split apart. And then I'm going to use the box here in order to factor out the greatest common factor. So I have a 5x squared and a 3x from both these. I can pull out an x. A 10x and a 6, I can pull out a 2. 5x squared and a 10x, I can pull out a 5x. And 3 and 6, I can pull out a 3. So I see in this case my factors are x plus 2 and 5x plus 3. And if we go to the next problem here, number 12, we'll solve it in the same manner. Start with your x, product of first and last, middle term, factors of 9, that will make a 10. And that pair should be right here, 1 and 9. Now you make your box. First term, first box, last term, last box. The 1 and 9 fill in the other two. Does not matter. I can put 9x down here, 1x up there. Then we pull out the greatest common factor. And there are my two factors. X plus 3 and 3x plus 1. And the last one here, start with an x. First and last is a negative 3 in the bottom. This one's pretty easy. 3's only got one other set, 3 and 1. So that's going to be 1 and 3. There's my negative. Then we'll make the box. First term, first box. And just to show you, I'll put the 3 down here this time. The negative 1 up here. Then I pull out the greatest common factors. And there we go. Your factors are 3x minus 1 and x plus 1. And we'll finish out this type of problem here on 14 and 15. And we'll get into the story problems. Product of first and last, middle term, and then we just find the factors. This is doing the exact same thing, but now it's putting it more into the quadratic representation in standard form and set equal to 0. But you can solve it and find those zeros the exact same way. And there they are. Look at the story problems here real quick. We'll finish this out. Now these ones can be done a little simpler. We can do them straightforward and still try to factor. But basically I have a rectangular quilt with an area that's equal to this. So if the width, or find the width rather, what is the width, if the length is x plus 8. So I could just factor this out and hope that one of them is x plus 8 and this is the other. You haven't learned polynomial long division yet, but that would be another means, but probably kind of cumbersome. But if you've played with these enough, you'll begin to recognize that this term here is created by this 8 and then this term here. So 8 times something makes it 24. And I know in this case that's got to be 3. And you can double check it to be sure. X squared, 3x, plus my 8x, plus 24. Combine the middle term. And I'll see that I get the same thing. So x plus 3 is the correct result. And we'll do the same thing here. I've multiplied this term, x plus 1 times something, is going to expand out to this. So again, the first term here comes from multiplying the two first terms. The last term comes from multiplying the last two terms. It's the crossover that creates the middle term. So when I already have one factor, I really don't have to worry about them too much, because I know that I'm going to need a 6x here, because 6x times x is the only thing that's going to produce the 6x squared. And if I have a plus 1 here, this is going to have to be a negative 2. And we'll do the same thing down here. Finish up the last couple problems. Area of a rectangle is this, multiplied by this, so I have 5x plus 3 times some other quantity. Again, I know that these two first terms are what creates that 5x squared, and these last terms are what creates the negative 6. So this one must just be an x, because x times 5x is 5x squared. And then if this is a 3, this one's going to have to be a negative 2 to produce a negative 6. So x minus 2 is my other term. And we do the same thing here. It's just a different way to express them. This one must be an x. X and x gets me the x squared. And then I have a negative 2 times a 12. And that's what will produce the negative 24. Again, the positive 10x results when I cross over x and the 12. That's 12 x's. And then come here, minus 2 x's. And I'll see this equals 10x. So I did do it correctly. So when you have one factor, it's pretty easy to find that last one, or the second one rather. So this one again, 2x to a 4x is going to have to be a 2x, and 5 is going to have to be a 5. And we're done. Good luck on the test. Bring any final questions with you tomorrow.